When using a mobile phone, things usually just work. Open a browser and the internet loads. And photos of Dash load. But as a developer, how do you know ahead of time if those network requests will work? The connectivity package can help with this. At its core, it tells you if the device is connected to a Wi-Fi network, a cell network, or nothing at all. There are two ways to use this API. The first is to immediately get the connection status. Start with constructing a new connectivity object and await for check connectivity. The result will be one of three things for what kind of network is likely to be used: Wi-Fi, mobile, or nothing at all. Check connectivity is an interface around platform-specific code that checks the state of the connectivity for each specific platform. And depending on how users use their platform, the connectivity might change. Enter the second way to check connectivity. Once you have a connectivity object, use onConnectivityChanged to register a listener callback. This gives you a subscription to a stream that you can use to update the status as it changes. The result will be one of the same three options as before. And that's it. With this newfound knowledge, you'll be able to know what kind of internet connection is available for your app. By default, scrollable widgets in Flutter don't show a scrollbar. That's fine in many cases, but in others you do want to display a scrollbar. Scrollbars show the user how far they've scrolled, and they allow things like jumping to a particular point in the list. To show a scrollbar, use the widget called Scrollbar. Wrap Scrollbar around any scrollable widget, like List View, Grid View, or Custom Scroll View. Make sure that the scrollable widget is finite. For example, if it's a listview.builder, make sure item count is defined. Otherwise, the scrollable widget doesn't know how far to the bottom it is, and therefore the scrollbar will not be visible. But assuming your scrollable widget is finite and you've wrapped it with a scrollbar, you're done. By default, the scrollbar will hide when it's not in use. You can force it to always be visible with is always shown. And by default, only the thumb is visible. That's the part of the scrollbar that moves. You can ask the widget to also show the track. That's the bar along which the thumb moves. Users can click on the track to get to that specific part of your list, and to show the track, use Show Track on Hover. Of course, scrollbars automatically work both vertically and horizontally, and you can style them any way you want using Scrollbar Theme.
Some designs call for rotating a piece of the UI. Here we're making the app a bit more interesting by rotating the headline by 90 degrees. To do that, just use rotated box. Provide the child and the number of quarter turns you want the child to rotate. 1 quarter turn is 90 degrees. This widget will take its child, rotate it, and then use its rotated size in the layout. This is in contrast with transform.rotate, for example, which will only affect rendering, not layout. The layout in transform.rotate will act as if the unrotated child is still taking its original place. Transform.rotate is therefore useful for animations and slight rotations, but for permanently rotated boxes like this, use rotated box. As always, it doesn't matter what you provide as a child. It could be a piece of text, some buttons, or a list of chips. As long as it's a widget, Flutter doesn't care. A common pattern in mobile UI design is to have a thing where you swipe it in one direction and it reveals some actions that can be done with that thing. There's a lot that goes into this interaction. Gesture detectors, transforms, curves, animations, click handlers, and more. It would be nice to just be able to use this pattern without worrying about all that, yeah? Well, you can. With the Flutter Slideable package, you get a slidable widget that implements this pattern. The typical use case for Slideable is in a list of items that share possible actions, like an email inbox. Take the list style you'd normally use for the item and add it as the child of a Slideable. Slideable needs to know how to show the opening of the list of actions. Does it expand each item as if they're growing to fill the space? Do the actions slide out from behind each other as if they're stacked up? Or maybe they slide in from off-screen? You define how this happens using the action pane property. You can either build your own animation for it or use one of the options built into the Flutter Slideable package. Slideable Scroll Action Pane, for example, will just scroll the action panel in from off-screen. But wait, which actions are we having slide in? For the Actions parameter, include a list of widgets representing all of the different things you want your users to be able to do with this slidable item. The package includes helpers like the icon slide action that you can just drop in to take care of sizing the action for you. Finally, set the action extent ratio to specify the fraction of space each action should take up. This should be based on how many actions there are so that all of them will be visible. And that's it. Now you have a list item with actions that can show up on a swipe.
All of the best apps start with a square squarely in the middle of the screen. But to turn this abstract idea into something more real, we need to think outside the box. If you look at a real, physical box, the only way you're able to see it is with some light, and that light casts a shadow. What if we want our abstract boxes to have a real shadow, just like a real box, so that our users have a mental model for what the things in your app are? Well, that's what Physical Model is for. Just take whatever widget you're working with, wrap it inside of a physical model, and give it a color. But wait, there's still no shadow? By default, Physical Model's elevation is 0, so we need to pick that box up to be able to see the shadow. But unlike the real world, we have additional options for our Physical Model created shadows, like its color. You can also change the roundness of the shadow's corners or simply update what shape it takes. But while fiddling around with shadow and shadow colors, you might be wondering why changing the color parameter doesn't do anything. What if you try changing the opacity of the box? What's revealed underneath the blue box? Physical Model doesn't cause the child widget to cast a shadow, but rather creates a layer underneath it that represents the object casting a shadow. And in fact, you could just leave the child off, but then this model doesn't take up any space, and so there's no shadow. Physical Model is super useful when you have ideas for custom shadow effects. It's also used under the hood in widgets like Material to build, well, material shadows.
Flutter provides Imagefilter, a low-level class that takes pixels and rearranges them. You can import it from .color.ui. For example, Imagefilter.blur will make anything blurry. Imagefilter.matrix lets you use any matrix for transformation, scaling, translating, skewing, rotating. The easiest way to apply Imagefilter to a widget is to use Imagefiltered. Just wrap the widget you want to filter with Imagefiltered and provide the filter so that the image can be filtered. Blurring is easy. Just use Imagefilter.blur and provide the amount of blurring in X and Y directions. Using a matrix transformation is a little more complicated. If you're a genius, you can provide the matrix directly as a float64 list. Most people will opt to use the matrix4 class from VectorMath, which provides constructors such as matrix4 rotation z. It's good to keep in mind that everything in Flutter is a widget. Therefore, you can filter anything, not just images. A similar widget to Imagefiltered is Backdrop Filter. Backdrop Filter lets you apply the filter to everything that's painted beneath a widget, instead of applying the filter to the widget itself. It's also less performant though. If you can do your effect with Imagefiltered, use it instead of Backdrop Filter. There you go! Imagefilter is an easy way to blur or transform pixels in your app. Flutter runs on a variety of devices, and generally speaking, you don't need to care about the specifics. But sometimes you might want to know the version of the operating system or the exact model or something similar. Enter device info. This package lets you easily access the underlying APIs, Android OS build on Android and UI device on iOS. First, instantiate the device info plugin. Next, Figure out which operating system your app is running on using the standard Flutter API. Then, run the OS-specific getter for the current platform, Android info or iOS info. Note that the result is asynchronous, so you'll need to wait here. That's it. Now you have the information you need.